Hello everybody and welcome back to Space Engine. It's been a good couple of weeks and, well, to get back to it actually. I've been playing a lot of No Man's Sky recently. Once I actually figured it out and got into it, it's actually kind of fun. A little grindy, but fun, I suppose. Anyways, where are we? A temperate ocean with life. I think we ended off here. My god, my throat's scratchy. There's like this dumb smog in my city right now, which is pretty uncharacteristic, but it's really irritating. Not as bad as last year. We had this really thick smoke that like choked us all August and most of July. It was terrible, but still, it's bad enough that I'm kind of noticing it. So if I sound a little scratchy or nasally or whatever, that's just that. Don't worry about it. I'm not sick. I'm just suffering from air quality. Right then, where are we gonna go? Oh, actually, I have a couple places to go. This one theoretically exists. Not found. Why does it not exist? What's to not exist about it? Let me check it again. What did I... Oh. Okay, I think I froze it. Oh, there we go. Why wasn't that working? Let's just try copying and pasting it again. Come on. Stop being frozen. Stop being frozen. There we go. No, not found. Let's try the other one, because there's two of them here. I'm probably doing something wrong, I don't know. Oop. Come on. Yeah, I need to stop alt-tabbing. Let's try this one. Oh, that one existed, kind of, maybe. Come back. That one does exist. Well, okay, I can go that one anyways. The other one wasn't working though. Strange. Anyways, what to talk about? There's actually a lot going on. Mars is at opposition. Actually, it was at its closest yesterday. But again, I couldn't see it because of smog, which is very unfortunate. I did see it pretty bright a few days ago, and my dad, who owns an observatory, says that it was really bright. This last week's where he was. So that's pretty cool. This is kind of an odd planet. Is that just radiant? Is that just radiant, or is it like all binary? Where's its sun? There it is. Well, let's check the planets here. Scorched Selena, Scorched Desert, Scorched Ice Giant. Wait, what? 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 Scorched Ice Giant? I don't think it works that way. Just throwing it out there, I'm pretty sure it doesn't work that way. Alright, Hot Selena. These are all pretty hot planets. Let's go to this one. Boom. Absolutely scorched. Where is that reflected light coming from? Is it just coming from, like, the moons, or is it just radiant heat? Or is there another star in the system? Curious where it's coming from the galaxy. Oh, wait, is that a comet? Oh, it's a comet. Okay. Wait a minute, it's not a comet. Those are the planets. This is quite the brutal system. My goodness. And what are yeah, those are like just being blasted away. I wonder. Can we speed this up? No, it's exposure. Look at that. That's a lot of material being blown away from the planets. Actually, you can see the wobble in the star, too. Around its very center. Let's focus on the star. Let's see, yeah. Well, that's not showing it, but this is showing the wobble. And that's actually how they find... well, one of the ways they find exoplanets is you look at a star, And if you're looking at the system disk on like this, then you actually can see the planets pulling on it and making it wobble around a common barycenter. Isn't that cool? Oh, and we're stuck on the star now. Oops. This star's barycenter. Oh, it's no longer registering. Well, whatever. Anyways, yeah, it's cool. Let's turn the volume back, or speed back down. Volume. What's actually the composition of this inner planet compared to the other ones? I'm kind of curious. Physics. Okay, I guess well, let's check the atmosphere, I suppose. 100% sulfur dioxide. What? With small amounts of other things: krypton, xenon, Cl2. What is that? Chlorine? Huh. That's weird. Why would you have a pure sulfur dioxide atmosphere? How thick is it? Oh. Oh, there's like none of it. Okay, that makes sense. Kind of like how Europa has like 100% oxygen atmosphere, but it's so thin, it's not really an atmosphere. Like there isn't enough of an atmosphere to really classify it an atmosphere. It's still pretty much a vacuum, but it has a very thin shell of oxygen around it. Unlike this one, mostly CO2, more complex compounds in its atmosphere. So a little bit more developed of an atmosphere. Still pretty thin, but thicker than the other one. What about you? What are you like? Alright, the info thing's broken. Oh, no, fixed it. It's more of the same, less complex organics in the atmosphere. But you still have a lot of carbon dioxide, bit of water. That's surprising. Sulfur dioxide, nitrogen, carbon monoxide, argon, neon, and krypton. Alright. So it's less developed than the other one, but still, pretty cool. Pretty cool. What about you? You're not... Oh wait, you're a gas giant, so you don't really matter. I only care more about the terrestrials. You're a hot Selena. It doesn't have an atmosphere. Alright. What about you? Also, no atmosphere. Weird. Well, I guess not weird. A lot of places don't have atmospheres. Mercury doesn't have an atmosphere. It doesn't need an atmosphere. It's cool the way it is. Well, alright, this was a fun foyer into that system. Am I missing anything? Let me check something. Has an ice giant that is the moons of a very pretty gas giant. Oh, alright. Yeah, make sure I don't miss anything. Oh my goodness, come on game. Stop freezing on me. Oh, and I broke it. Let's just go back to that system quickly. Make sure I didn't miss anything. I don't think I missed anything. These are mostly just scorched asteroids. Yeah, it's kind of cool, actually. That is kind of cool. Gosh, I wonder if I can up the exposure so I can see more of it. Huh. Interesting, interesting. But let's get out of here and find something else to do. Where are we? We're in some random galaxy, aren't we? Last I checked. Yeah, we're in some random galaxy. Well, let's see what lies beyond. That's a good question. Where are we going? Oh, screw it. Let's just find some random star and go. With or without life. Sure, we'll go there. It has 11 planets. We can probably find something interesting here. Ooh. Ooh. I'm correct. There is something interesting here. A hot oceana. I wonder if it has like a steam atmosphere. Let's find out. Atmospheric pressure. That is a dense atmosphere. And it's mostly carbon dioxide. A lot of water though, so it's kind of a steam atmosphere. Very complex. Look at that. Oh, look at that ammonia. Wait, NH3, it is ammonia? Yes. Nitrogen, some of the ethane groups. CH4. Again, I always get these mixed up. Is that propane? Ethane? Acetylene? Let's check something. I should probably just like have these written down next to me. Yeah, it's methane. I should have these like written down next to me because I'm always doing this every time I play. I get confused by the hydrocarbon groups, like the methanes and the ethanes and the propanes and acetylenes. Whenever I do organic chemistry, they always trip me up the most. But I always remember ammonia. Always remember ammonia. And all the elements are pretty easy. Chemistry. That's a really nice planet. What else is going on here? Oh, you're boring. Black hole. Really? Whoop. That's an interesting shot. Let's back away a little bit. Oh, look at that! You can see the light from the star on the other side, because the light bends around it and lenses around it. That's kind of cool. I will say I like how Space Engine simulates black holes. They do a fairly good job. Pretty nifty. And you can see the space behind me too, a little black outline. That's cool. I love it. I love black holes. They are pretty cool. I remember this one time I was reading this thing about like how to make a spaceship engine using black holes, and like, well, it's more of a Hawking radiation engine. Like what you do is you create a black hole that's small enough not to cause problems, but big enough that, you know, it doesn't evaporate immediately. And then what you do is, oh, look at that. And then what you do is you basically just let it evaporate, and you direct the Hawking radiation out the back, and that pushes you, and you would get a very low thrust, but it would be able to burn forever, basically. Well, until it evaporated completely. So like there'd be like no real fuel usage, just the black hole evaporating, and you can push up pretty fast. So kind of cool, but it requires making black holes, which I guess technically we can, but the black holes we theoretically might make are like the size of molecules, and they evaporate within millionths of a second, so like within super colliders. The whole idea about like the LHC making a black hole that consumes the planet doesn't actually hold water, because any black holes that could be made there would be so tiny they'd evaporate like immediately. Because black holes do evaporate. Like, a lot of people know that, but they're not permanent. They actually do, as well, again, conservation of mass. They dump out Hawking radiation, and if the black hole isn't feeding and it's just radiating Hawking radiation, it's going to lose mass, and very slowly, mind you, but it'll lose mass. The bigger the black hole, the slower the process seems to be. Well, it happens proportional to the black hole's size, but bigger ones, it takes much longer because there's more mass to, you know, radiate out. Whereas small ones, there's less surface area to radiate out, but there's so little mass that it does evaporate much faster. Or, yeah, you know what I mean. Shut up. It's kind of similar to the, like going back to the engine thing, kind of like the black body radiation engine, where you just use like photon energy from a radiated mass to push yourself. Whenever I think about that, I always think of like thermal photons, where you take like a graphene or a tungsten. Like, I was thinking more like a graphene plate with a tungsten coating on one side, and the tungsten coating, maybe not tungsten. Actually, yes, tungsten. and you have the carbon, like I guess you can make it out of nanotubes or graphene. You have that side as the actual pusher side, and the tungsten as the like the input side, and you basically just dump lots and lots of thermal energy into the graphene, which then radiates out as thermal photons, and it pushes you forward. I love graphene because it's incredibly thermally conductive, but very lightweight. It's carbon. It's great. So you could theoretically dump a lot of thermal energy into it. And the more energy you put in, the more photons come out, the more thrust you get. It's still very, very little, mind you, but it all adds up. I'm talking like a relativistic starship here, so you accelerate for like years. But back more down to Earth, I've been working on my rockets some more, because my financial situation's actually improved a bit, which is nice. So I might be able to actually get some more work done on the balloons and whatnot. But I was looking at the rocket program, and I'm gonna start doing like building the first like peroxide rocket here soon, whenever I can get the parts. Still haven't sourced the peroxide, but I'll worry about that later. But I was thinking, for the 3rd generation rocket, because the first one is technically the one behind me that hasn't flown and might not ever fly, but the 3rd generation rocket, I was thinking of doing a kind of a 2-stage without staging kind of thing, where you have where you have like jet engines around the like the base of it, which give you your initial thrust, and then once it gets to a certain altitude, turns those off, and then switches over to the peroxide rocket and carries the rest of its way into space like that. Again, this isn't a new idea. It's been thought of for orbital rockets and stuff, and SSTOs and all that, but I'm just going for suborbitals, so I don't really care about all that. But I'm really liking the idea of a jet first stage, which then carries the rocket up, and then it peroxides up the rest of the way, and then it rotor descents down. And that'd be pretty cool. And I was actually thinking, it's like, if I were to build something like that, I'd need one of those, like, basically like a model jet engine to use as the jet engine, because it would be a smaller rocket. And I was like, how much do those cost? They probably cost a lot. Lo and behold, I checked. You can get a lot of different types for like $45. So I was really surprised about that. I was expecting them to be much more expensive than that, but apparently they range in price, but they don't actually have to be that expensive. So that's kind of cool. I'll keep that in mind, because you never know. You just never know. What is on my thumb, and why does it hurt? That's really weird. Oh. Anyways. So that's been kind of fun. Lots of good stuff going on in those areas. I need to actually start building the rotor for the balloon, like to test the descent system. And actually, with the rockets, if I go with the jet engine ascent, I could theoretically use the jet engines for landing too. But again, I like foolproof, so I might just stick with the rotor system for recovery and descent, because it's just way easier than having to program a computer to like control the jet engines for landing. So we'll see. The first peroxide rocket will have the rotor descent system anyways, but at this point it's looking like I'm gonna have like a three-stage system, where it's like jet engine, rocket, and then rotor for descent. But it would all be one compact thing and completely reusable, so I don't care. Oh man. And it's August. August is fun. I'm actually looking forward to October. I love Halloween. I always do Halloween stuff. I go to a party every year, and I always do a different costume every year. And oop, go away. And this year I had 3 ideas for costumes. I was thinking either what were they? It was like the uniform from the first Alien movie, like the Nostromo uniforms. What was the other one? I had 3 of them. It was like Nostromo, something else, and then Starship Troopers. I forgot what something else was, but anyways, I decided to go with the Starship Troopers one, where I'm gonna go with the Sky Marshal from the Starship Troopers movie, because the uniform is incredibly easy to make and incredibly cheap too, which works for me. And also, if I have that uniform, I can ensure that human civilization and not insect dominates this galaxy now and always.
To ensure that human civilization, not insect, dominates this galaxy now and always.
Sky Marshal Beans announces plans for an offensive against Klendathuri, source of the bug meteor that destroyed Buenos Aires.
So that's gonna be fun. I love that movie so much. I love the movie and the book for different reasons. The book was a political thing that Heinlein angrily wrote because, well, he was, you know, height of the Cold War. He was honestly concerned that humans were going to exterminate themselves. And, like, what was it? It was like he moved his house in the middle of absolutely nowhere, and then NORAD built, like, actually, I think it was like the Cheyenne Mountain Complex, like, right by his house. And he got angry because that made it, you know, his property, like, prime nuclear target. So he, like, angrily wrote Starship Troopers as, like, you know, this is my idea on how to save the human race by having a unified military-based government. And this planet is vibrating, and it's actually really cool. The book is very political. It's very interesting. If you haven't read it, I highly recommend it. He tends to, like, Heinlein tends to, like, go on tangents a lot, but they're good, don't worry. Whereas the movie was a fascist satire, which, it's kind of funny. Like, people will see it, and, like, they watch it, and it's like, a lot of the aesthetics and stuff seem very Nazi, and it's kind of weird, and it's like, that's the point. It was supposed to be that way. Like, Verhoeven, I think that's how you pronounce his name, the director of the movie. After the movie came out, a lot of, like, especially Eastern European countries got mad at him, and were like, you know, threats and all that, and he wasn't allowed to, like, go and all that. But then people started realizing, oh, wait a minute, it was a satire. Like, it wasn't glorifying fascism and Nazis, it was kind of making fun of them, and showing that the system is actually kind of broken. But and then everyone started apologizing. But it's actually a really great movie too in that respects. Like, just in terms of just fun, crappy science fiction, it's a lot of fun. And then if you, like, pay attention to it, you can see that it actually really does poke a lot of holes in fascism, and it kind of makes fun of the whole institution. It's great. I love it. I love a good satirical movie. But yeah, anyways, that's 20 minutes, so I'm gonna end it there. So thank you all for watching. I hope you enjoyed. I'll be back with more later. I might do some more No Man's Sky because it's kind of fun. Yeah, so thank you for watching. Hope you enjoyed, and space.